again to Doozer's shop. Has been a while. I just kind of wanted to do a random update, show you some of the things I've been working on. Alright, we know you guys love handheld. Let me start at the Rockford planer. Alright, let me close this up here. Alright, so we've been working on this is an adjustment for the stroke of the step over on the cross rail. And as you can see, somebody has broken this and attempted a repair, and it is missing a piece, and it's just, yeah, needs fixing. So I kind of started looking around at what we got, and the shaft here is 5/8 with a you can see that 1/8 key, and usually 5/8 has a 3/16 key, but I've seen a lot of hand wheels with the 1/8 key. It's a Woodruff key. But anyways, I got to thinking, and then it dawned on me, the side the slide for the side cutting has what looks to be an almost identical handle to what a Bridgeport is. So that's what I did. I got a Bridgeport handle, and it fits on there. So let me kind of show you. Let me take you over to where I got it. Alright. Kind of go over to the SIP. Well, first of all, let me take you to the Bridgeport. So, typical, yeah, pardon the extension cord, Bridgeport handle. I snagged the handle off that side. But they're 5/8 bore with a an 1/8 inch key. So let me kind of zoom you over here what I did. Maybe that's a good shot. I took a handle and I needed to thin the hub down. Okay, kind of walk around the other side. You know I'm awful tight in here. So I needed to thin it down. Okay, that's a good shot. The Bridgeport handle, the thickness of the middle hub where the lead screw shaft goes through was an inch and a 1/16, inch and an 1/8. What I end up doing is, well, it doesn't matter, but that's 3/4 of an inch. So what I had to do is I had to mill off both sides. I had to take like 1/56 off that side, and I had to take 1/56 off that side, you know, which is 5/32. It was 5/16 too wide overall, but 3/4 wide is what the old the hub on the old broken crank handle measured. So I got it set up in the vise, and I had the idea, you know, because these are round balls on both sides and I got the handle sticking up, they fit in, you know, the bolts, the Allen head bolts that attach the jaws, it fits in there perfectly, you know, on, you know, both sides. So that's what I did. And you know, anytime you load a vise with just one side, you should pack the other side. Now, I know with Kurtz it's not as much of an issue as the old style milling vices, but you might be able to see and keep the camera straight. And I apologize if the lighting's awful. I got a couple 1, 2, 3 blocks in there. Well, I got a 2 and I got a 1. I could have just done 1, 2, 3 block, a single 1, 2, 3 block. I wasn't thinking. But anyways, and then there's a machinist jack. Yeah, I should have just used one single 1, 2, 3 block. Oh well, can't think of everything. Hindsight, you know what they say. So what I did is I got that handle in there, and then I clamped a parallel to it, and I indicated it up and down, kind of show you. I just took that, and I clamped it vertical with a C-clamp, and then I indicated it up and down. And then additionally what I did is this is 5/8, I had a 5/8 dowel pin I put in also horizontally, indicated the high point of center, and I indicated it in this axis also. So I knew by indicating it with 2 different methods that, you know, the bore was perpendicular to the surface that I was cutting. And I took a skim cut. I only dialed in 1/1000th of an inch, and you could just see it was making contact, you know, all the way at the top and all the way at the bottom with just 1 thou. So I was within, I think, a 1/2 thou. So I used the side of the end mill. So I milled that side and that side, you know, and I didn't move the part, all in one clamping, as they say. So these sides will be as parallel as the end mill is ground straight, you know. So that's what I did. And to get a good, accurate measurement of how much I was taking off, and I know this is a Swiss jig bore machine, and it's got the, you know, it's got the super accurate dials, and it's got the, you know, the linear cam mechanism for, you know, following super accurate, and this is actually the linear cam goes under. But man, dials are so hard to keep track of, and there's only like 2 or 3 thousandths of backlash. But what I did is I set up the old dashboard gauge travel indicator. It's a 2-inch dial indicator, and it's got this reference rod to tell you the nearest inch and the scale. But what I did is, you know, I ignored even the pointer. I got this little angle bracket. There's the thumb screw. I attached it, and I just got my indicator on there. So I can take off 156 per side. I can exactly measure, easily measure the travel of this bridge axis. You know, this is as accurate as can be, and it really is. But it all goes out the window if you make a mistake in left or right, or you take the backlash or you don't take the backlash out. And you know, this will get you close, and as you saw, I used the micrometer to measure it when I was really close. So that's a good thing. I'd like to get digital readouts on this guy. So this is kind of cool. You guys might think it's a little bit of hackery. I got this a long time ago. This is from a laboratory chemistry setup for it's used for like holding Bunsen burners and glassware. It's sort of a universal like chemistry lab kit. It's like a V groove, and it's a thumb screw. And I've used it for many things. I used to have a soldering iron holder attached to it. Well, it's made for having gripping on a flask is the other piece that used to be on there. Maybe I've lost it, I don't know. But dial indicator linkage, man, building stuff up, you know, sometimes it's a challenge. But this is so stone simple, but it works. And yeah. So anyways, so, you know, I gotta apologize, sort of. One of my viewers, my subscribers, volunteered, we collaborate on the phone sometimes, volunteered to do this job for me because he had a spare handle. He was going to cut it down and send it to me. And I did not follow up and give him the measurements. Gracious of him to offer me his spare handle, and I will accept it to put back on the my Bridgeport table. But thank you, Mark, for offering. And we talked about putting it on a mandrel and spinning it in the lathe. And I didn't measure to know if I needed one side or the other side or how much. So I just got with it today. It's a Sunday, and I kind of was itching for a mini project, so I did it. So that's gonna go, and like I said, I'm too lazy to edit videos, or else I'd clip and show you putting it on. But anyway, so that's that. I got it milled down exactly. I think it's like 2 thou over 3/4. I'm gonna just lightly file the surface and deburr it, because that's what the old one was like. 2 thou over 3/4 of an inch. So it's exactly what the other one was. And I got some play. I got like 50 thousandths, additional clamping with the thread on that nut. But I just wanted to show you that. Now, let's see. I don't know if I showed you guys this. Forgive me if I did. This is a magnet, and I made I got my indicator on it. It's a surface gauge, and I made a new little handle thingy for it to turn the magnet on and off. So that's cool. And I had this green thing. It's like a Tiny Titan. I don't know. Whatever. Kind of fun. So I was playing with indicators and linkage, and I got, you guys seen this thing. It's like a Noga, but it's made in Germany. Kind of cool. All right, enough of that. Anyways, let me kind of show you. Oh, I want to show you. So this is an additional headstock for a Brown & Sharpe 13 grinder. And I got it from a gentleman in Boston, New York, like Hamburg, New York, when I was up getting the planer. So my buddy Mark grabbed this for me. I bought it on eBay. Pretty good price. And I'm going to make, so right now, it's got the Brown & Sharpe spindle. So it's got left hand Brown & Sharpe type proprietary thread, and it's this number 7 Brown & Sharpe taper. And I've got this spindle from a Harding AHC. It's like a CNC Harding lathe. And this I'm going to fit to the secondary headstock, and it's got the 5C collet and a Harding 4-degree taper. And I don't even know if these bearings are good, but measurement wise and length wise, like this bearing will actually fit in the casting. The bore is the same size for the bearing, and the rear is a little different. I don't know if I can find another different bearing or bore out the inside. But enough of that. That's another project. Watch this space, as they say. Oh yeah, there's the base of it that I took off right there. So that's going to go on, and we should be good to go. I'll show you in the next video I make. That's the old one. The new one will be there, and it'll match the handle. Oh yeah, so this is cool. Let me give you a straight on shot. That silver handle, crank handle, you can see it's bent to miss the shaft, and obviously this one is going to work as well. And I thought I had this came with my Clausing 8520 mil, but it's perfect. Like the bend, I didn't know why the bend was there. Like this one, there's no bend in it, and it'll hit the shaft. It'll come bloop. It'll just barely hit it. That one. So I'll leave that one for the elevation, and I'll leave this one for the cross rail. So yeah, that's a Fairmont crank. So that's dandy. So another score. At work, they were throwing away a Kearney and Trecker number 2 horizontal mill, and I saved this off of it. This was to put the rams in and out, and the machine they ran it out of oil. Somebody ran it out of oil and just locked up the gearbox and the spindle, everything. So it was sitting out back for junk, for dead. So I don't know what the is it a Z or an N? Could be a Z. But I got this off, and I wire wheeled it, all the paint off, And I'm going to use this on something here in the shop because it's really a great looking handle. So anyways, until next time, this is the update from Doozer's shop.